Greetings and salutations. This is Chapter 5, Part A. We're looking at the periodic table, and you can see the homework here. We broke that up into parts. Let's get to it. So the thing is, the periodic table didn't develop overnight. It was something that took time, and it took different people. The first dude, Lavoisier, he published a list of over 30 substances he called elements in 1793. That's what it was published. But this dude did lose his head in the French Revolution. He is there with his wife. Yeah, their hookup story was quite interesting. But some of his elements were actually compounds. We talked about Dalton a little bit. He eventually documented as many as 60 elements. He had a complex symbol system. In 1829, you had Dobereiner, a German dude, which many chemistry documents, in fact, are in German. So, the triads. This is not to be confused with the game involving triads, criminal organization. No. The triads are groups of 3 elements that share similar properties. And some triads became tetrads, meaning 4, and pentads, meaning 5. There seemed to be the idea of periodicity. And there seemed to be lithium, sodium, potassium. There seemed to be a difference in the number in their weights. And the same thing with the salts. So there was, in other words, we're seeing patterns. Okay? Newlands in 1865 organized the atoms by atomic mass. He used musical and a math background to do it. And there were 7 columns. Now, he also came up with something called the law of octaves. So in other words, there was a connection between atomic mass and the chemical properties. Well, what do we mean by chemical properties? We have to go back to like chapter 1 or 2 and understand is how do the atoms behave? How do they act? Okay? Too bad nobody accepted the idea. That's just the way it was with them. Now, Mendeleev was a Russian dude, and that was around the same time, roughly. He arranged the elements by atomic masses. Now, what he understood was when he created his version of the chart, he knew there were things that weren't discovered yet. Excuse me. But there were transition metals in there, and that there was some kind of a periodic law there. Something was acting. Properties of elements vary with their atomic masses in a periodic way. In other words, we're seeing a pattern in terms of what these elements were and how they acted, how did they behave, which again points to a distinct creation. It's not an accident. There are patterns that happen in creation all the time. Now, modern periodic law, we can talk about Henry Moseley, and he came up with the idea that properties of the elements vary with their atomic numbers in a periodic way. That is a picture of the guy. Too bad he was killed in World War I, and because of that, scientists were never allowed to fight on the front lines ever again. It's just the way it was. We do have artificial elements out there like transuranium elements, like neptunium and plutonium. Those are products of artificial processes. We do not find them in nature. Yes, they are radioactive, okay, and they are expensive to make. So let's take a look at some pieces of information that we would find on a periodic chart. So here we have one element. We have the symbol of radioactive, radioactive, and then here we have the atomic number, which you might possibly remember for the last chapter, chapter 4. We talked about the number of protons there were in the nucleus, because that's the identity of the atom. That's a key thing. And we also have the name, uranium. We also have the symbol, U. U! The atomic mass, 238. So think about the number of protons and neutrons together as an average. And then down here, which you won't have on your periodic chart, but it tells us the electron structure by energy level, level 1, level 2, level 3, 4, 5, 6, and 7. So that's our basics. So here, a vertical column and a horizontal row. Now that's a pretty key thing when we look at the periodic chart, because if we're going up and down, those are known as groups. Okay? We also call them families. If they go across horizontally, Those are known as periods. Okay? So when we go and look, at a periodic chart like this, then we have our groups, like group 1, group 2, 3, 4, 5, and work our way through to group number 18. That's just the way how we see this. Okay? And the reason why they have the different colors is that they belong in certain categories, which we're going to get into in the near future. So we can look at metals, nonmetals, and metalloids. Metals are to the left and pretty much the middle of the table here. Okay? Nonmetals tend to be on the right-hand side. Metalloids share the properties of both metals and nonmetals, so they're bi-characteristic, if you will. Okay? So that's what it is. Now, we do have something called the lanthanide series and the actinide series, and we have them on the bottom of the table. And what you may notice, compared to the previous chart here, our lanthanide actinide series are on the bottom here. And there is a reason. They do go in here, but if we do it this way, while this is considered correct, okay, we took those out, stuck them on the bottom, so that we can actually have a more manageable periodic chart. That's what we've got going for us. And with that, ladies and gentlemen, this is our quick intro to chapter 5A about the periodic chart. Hey, I hope this has been a blessing to you, and stay tuned, there is more.